Hello, this is Karma from Karma Logic Min Pixel Studios. Thank you for visiting the Monica Motion Dark Science investigation today. Our mission is to keep you informed about issues which have an effect on our lives. Today, we have a recent NASA public publication concerning the Sun and new predictions for when the solar maximum will occur and the polar flip, which will follow. NASA begins with a bit of history, as they should, concerning a solar event which burned down our primitive electrical grid in 1859. Because this NASA video was so well done, we used the best animations with yours truly as your narrator. Coming just a few months before the solar maximum of 1860, numerous sunspots began to appear on the surface of the Sun on 28 August 1859 and were observed by Richard Carrington, who produced detailed drawings of them as they appeared on 1st September 1859. The same day that the sunspots appeared, strong auroras began to dance around Earth's magnetic lines, visible as far south as New England in North America. By 29 August, auroras were visible as far north as Queensland, Australia, in the southern hemisphere. The spectacular auroras awakened gold diggers in Alaska, who thought they were seeing a rather unusual sunrise, and began working as if morning had arrived. Similar accounts were reported all around the world. 17 hours after Carrington witnessed the solar flares he saw, which he said lasted 5 minutes, telegraph lines were hit by the dense fireball of solar plasma. As the electromagnetic energy burned through our vulnerable wired telegraph system, it burned operators, as well as burning down a few structures. Incidentally, our electrical grid is just as vulnerable, and probably even more vulnerable now than it was in 1859. Sunspots are electromagnetic field lines popping out of the surface of the Sun and usually appearing in pairs. They appear dark because they are cooler than the surrounding surface of the Sun. During a fairly reliable 11-year cycle, the number of sunspots increased steadily, termed the solar maximum cycle, until the north-south orientation of the Sun's poles flip positions. We see graphically the data which astrophysicists use to make solar activity predictions. The upper limit of the lines is the solar maximum, occurring every 11 years, and truly represents a time of chaos both inside and outside of the Sun. The top of the dashed line is where we are at in our march up the solar max ladder at this moment, March 2024. During the solar maximum, highly energetic sunspots migrate far from the equator, just before the north and south poles exchange their orientation. This simulation illustrates how stable-looking electromagnetic field lines become tangled and chaotic when approaching the solar max. Note that the field lines, next to red arrows, are bursting out the surface of the Sun as the solar max approaches. If the electromagnetic tangles becomes too unstable, it will explode plasma out into space. These mass ejections can be somewhat weak or, as with X-class flares, outrageously strong. And finally, they are indiscriminate about their trajectories. Coronal mass ejections, or CMEs, may hit planets, like Earth, or miss them altogether. When solar events are minor, we can all enjoy the colorful light displays. However, there is more to this story than augmented sunspot activity and colorful lights. Just as an electromagnetic field protects Earth from deadly radiation coming from the Sun protects the entire solar system from the extremely high velocity ions it encounters from supernova events. According to NASA, the poles will flip within the next 3 to 4 months. This graph illustrates how far the sun has strayed from the predicted path in this cycle. Starting at the 2020 solar minimum, it quickly became clear, note yellow line next to the red prediction line, that sunspots were propagating faster than they were expected to. The new prediction represents both an increase in the number of currently observed sunspots, as well as an overall increase in the total number of sunspots manifesting themselves at the solar maximum. Stanford's Wilcox Solar Observatory is one of few observatories in the world that monitor the sun's polar magnetic fields. They have been tracking the sun's polar magnetism since 1976. During this time frame, they observed 4 polar flips. Note that there is a brief amount of time when the sun has no magnetic field whatsoever. The sun's domain of magnetic influence extends billions of miles beyond Pluto and is known as the heliosphere. The sun's slowly rotating magnetic field induces about 1/10 billionth of an amp per square meter, 10,000 kilometers thick and billions of kilometers wide. During field reversals, the current becomes very wavy. As Earth orbits the sun, it dips in and out of the current. When Earth is outside the current, we are no longer protected from cosmic rays, accelerated to nearly light speed, emerging from supernova and other energetic events in the galaxy. Astrophysicists suspect that cosmic rays striking Earth may cause climatic changes, like cloud cover. Obviously, this would be bad on many levels, adversely affecting our ecosystem and the biological life forms who depend on it. Not to mention the possibility of damaging orbiting satellites, probes, and those brave souls who venture out and into space. At the moment, the poles are oddly out of sync as the North Pole is already shifting while the South Pole races to catch up. A sure sign, say the scientists, that the poles are about to flip soon, probably in the next 3 to 4 months. We will keep you updated as the sun follows along its unpredictable path. Until then, this is Karma saying thanks for tuning in to the Monica Motion Dark Science Investigation. And remember, Karma logic suggests that every bit of light you see must first navigate the darkness. Bye now.